live. I forgot to start imvu, which takes forever to load up. So hello everyone, continuation of Turkey. So previously we oh, I need to turn the music down. Right, so previously we set up the furniture item so that it has a furniture root node and is controlled by a Turkey control, which is another node, and that in turn controls the skeleton, which in turn controls the mesh. But as per what we were doing yesterday, this works to a degree because it's just a very limited product. So let me just load that up. Should have done this before starting. Right, so which one is it? Static. So initially we created a static furniture item. We created a static furniture item, so we just parented the mesh to the root furniture skeleton, which we used on import. This doesn't do anything. So in Blender, that was just the mesh parented to the root node. So we wanted to add a bit of animation to that, so the next thing we did was added a simple bob animation. Bob, short for Kate. Which we created an action for, which is triggered by typing a word, in this instance Turkey Bob, short for Kate. Turkey Bob. So when we trigger that, a simple bobbing animation occurs. So the next step from that, so that's created using mesh, but it's being controlled by a simple armature now, which is then parented to the root node. So that's the furniture root node, controls everything as per normal, but to get the bob animation, we have to use, in this instance, we have to use an armature skeleton, because we need to control more than one element of the mesh, which we can't do with nodes in this particular instance, because this is a single object, a unified object, and we can't have a unified object controlled by multiple nodes. So we have to use a skeleton instead, or an armature. And that allows us to create bob. So the next step from that was to add a hop. And again, this was triggered, so we've used the same skeleton, we're still using the same skeleton, we're still using the same mesh, and the same materials, and we've created an additional set of actions. So we created, using that new skeleton, or the modified skeleton, and the modified skeleton in the sense of the entire skeletal control system, which is essentially these three components, that allows us to create another animation. So we want Turkey move. Turkey move. So we've got a separate motion animation which just loops round and round, and then the other one was Turkey hop. So Turkey, click the 3D view, Turkey hop. And that then plays two sequences at the same time. So we've got the animation going around in a circle, and then we've got the cycling hop animation, which just basically has the character moving up and down on a spot. So I will just close these, otherwise they'll be running in the background whilst we're doing this using up CPU. So the next step is, so we've got a hop animation, we've got a bobbing animation, but if we wanted to do more to the character, we can't just, as we did yesterday or in the previous session, we can't simply just add extra bones to the skeleton, because the control of the mesh needs to change. At the moment it's the leg. Hang on, I'm just going to make this easier to see. Changing a theme. Theme. There we go. That should be easier to see. Although the grids disappeared. Is that because of the colour or? Yes, that's the colour. Okay. Unlike the previous session, we can't simply just add bones to this particular structure the way that it currently is, because the control of the mesh is at the legs, and we need that really to be in the body or the torso. So what we have to do is essentially rejig the armature to then allow us to do what we need to do to the rest of the character. So what we will hopefully, if we get time, well, we will, what we can do is add a bone for the tail, a bone for, we can either do one bone for one wing, one bone for the other, or we can have one bone controlling both of them. We need a bone for the head, and then we should be okay with the remaining structure that we've got. So what we need to do first is clear the parenting of everything. So let me just move this out of the way for the moment. Move all of that. Whoops. Move all of that to that layer. So we have this isolated. Right, so the first thing to do is just clear all the parenting. So select everything, right click the root node, and then use Alt P. We want to keep transform, or alternatively object menu, where's parenting gone? Parent, and then we want parent clear and keep transform. And what that does, The keep transform is important in the sense that if you don't do it, and this was positioned, let's say, over here when you parented, keeping transform will keep the position of the object where it was when you parented it, rather than resetting back to 0, which is what it would tend to do. So, armature, and this will need us to we need to do two things. We need to create a set of vertex groups, additional vertex groups, and then we need to create the bones. So what we can do first is create our vertex groups. So mesh, edit mode, tab key, and then we need to object data properties, create a new group, and then just select, make sure everything is deselected, so press the A key. Make your selection, that's control left click drag, that's loop select, and just assign that, just so that we have it assigned. Use your mode selectors, so vertex, edge, face, to then select the remainder of the element that you want this particular group assigned to. So that was an alt right click which selects the loop. So right click selects individual faces, shift right click multiple faces, and then alt right click will select a loop or an edge loop, whether that's faces, vertices or edges. So then you can shift right click, add other faces to that selection, and then we want to assign, double check, rename tail, and we will need to clear, because we should still have torso assigned there. So if we select the vertex group, torso, and select, it will select that group. So what we have to do again, as we did yesterday, clear the selection, select the tail group, then select the group we need to remove, which is torso, and click the remove button. And that will remove that group from that selection in the 3D view. So that won't do anything. Well, it'll select the rest of the, but it won't select that section. Yes, Turkey's name is Bob, short for Kate. That's a Blackadder reference for those that don't know. So we need one for the head, and for this we need to include everything that's in the head. So that's this section. So we may need to do some, this is where loop select, lasso select comes in handy, because you can make reasonably precise selections. We'll just clean that up in a second. Create a new group, double click, left click to rename, just call that head. That'll do for now. Switch between wireframe and solid mode to help and to aid your selection. So we need these top faces and this edge. We need these rivets. So control left click. That will include them in the previous selection, so we don't need to do anything there. So we've got the top rivets, top. So just double check, press the G key and see if we get any stretched elements, and we don't, so that's excellent. So we've got that selected. Assign the group that we created head to that, and then double check, and again of course torso is assigned to that, so we need to clear that again, doing so clear that selection, that's A. So we need to select the head, select the vertex group we want to clear, and then click remove. So if we clear that selection now, that will only select what's left of the torso. So next, wings. So we need to set up a wings vertex group. So again, add a group. So that's click the button, double click, left click, wings. And for this, could be tricky doing this. Let's see. So deselect everything. Using lasso or loop select again. We'll probably just do a rough selection. That's included some elements that we don't need, so we can toggle circle select or paint select, and this gives us this little circular widget that we can use, and that's select, circle select or border select. So note the shortcut key, that's C, the letter C for Charlie, or B for bingo, and then you can use your middle mouse to scroll up and down to increase or decrease its size, and then middle click to clear the selection. Toggle to solid mode and just get rid of these. So what we should have is just the wings selected, which we do. So assign, deselect, and again we need to remove the torso group that's assigned to the wings previously. So using the group assignment we've just created, select the torso and remove. And that will have no influence on those wings, which will now mean that it'll just select the torso. So what we've got now is torso, legs, that's just the uprights, toes, the tail, the head, and the wings. So this will allow specific control of those over those elements by bones that we can then add that will control those sections of the mesh. So this is why you can use, you don't necessarily need to use, if it's a simple furniture item or a simple item, doesn't matter what it is really, you can just literally parent a mesh to the root node, and so long as you have them parented, the FBX exporter will recognize that there is a hierarchical relationship between the two, and it will produce a functional item once you import them into imvu. So you don't specifically need to set up vertex groups. The only time you really need to use these is when you want to start, when you want to have more specific control over particular areas of the object with a more complicated skeleton, which we'll now sort out. But these vertex groups aren't specifically necessary, but it depends on your item type and what you want the object to do once you get it into create mode. So let's save that. Save as. So we've got 25. Yeah, so this is 26. So next we need to add, we've already got torso bones, bone, we've got a leg bone or legs, and we've got toes. So we need to add tails, wings and head. But as mentioned, at the moment, whoops, so we've got the torso affecting the torso, we've got the foot or toes affecting the toes, but at the moment the legs control, well, they don't, it doesn't control the entire thing at the moment because we haven't got bones associated with the sections that we just created, but you can see in principle exactly what is needed and why you need the bones, because we don't have bones to specifically control the areas that we've just marked. When we move what we do have, it only moves the bits that we have linked together. So edit mode, what we need to do here is change this around a little bit. So perspective, right side. So we want what is now the legs to be the torso. We just put it roughly there. And we want the torso to be the tail. So this now means that when the torso, well, what is now going to be the torso bone, that's the control of the entire object. Whoops. There we go. So we can rename this, right click select. So that's, oh, we actually need to rename the armature as well. So Turkey, no, leave that for now. Let me just make a note of that. Right, so we need to rename this. So bone properties, or object properties, it's called legs at the moment. So we want to call this torso. Which will automatically append the unique identifier .001, or if there were, because we've got a multiple, we've still got the original torso bone in place, so we need to change that, make that tail, so we can then rename this back to torso. So this should now mean, yeah, so the torso moves everything, the tail, well, it currently moves more than it should do at the moment, so I'll have to double check why that's doing that. But it should be just moving the tail. So that could be because it's probably renamed the group, because these bones were called something else previously. So when you rename them, Blender will automatically rename the groups that are associated with them. So we need to double check that it's done that. Yes, it has. So tail. So if that's selected, yeah, so it's created torso there. So this is one of the disadvantages of modifying things after the fact, because this basically destroys the structure that you had previously, and it also means that the animations that you had previously will also be redundant. I mean, a way around it would be to just add extra bones based on the armature setup as it was, but that doesn't necessarily mean that you're going to get the full control that you need, because we actually need the character to be split in two essentially at the hips. So the torso bone controls the upper half of the character, and then the legs bone, which we'll add later, controls the legs and the feet. In the previous iteration, the torso, well, the leg bone, it's now torso, but the leg bone was controlling the entire object, which makes it difficult to do any complicated animation. So this is the consequence of that. If you start juggling the bones and renaming things, it also then renames everything else, and you have to then tidy up all of that readjustment. So this is always why it's a good idea to have it's always a good idea to have an idea of what it is that you want your object to actually do. So yes, Debs, you could, I mean, that is what we will be doing. We'll be adding more bones, but adding more bones to the structure that we had isn't going to be optimal for what we want the character to actually do, because the controls are the control orientation is set up different. So it basically means that what we want, as I said, is that we want the upper section to be separate in a sense from the lower section, the feet. But the way that it was previously, we don't have that separation. So we can only do, it limits the amount of, it limits the type of animation that you can do. Yes, I mean, that you could do that and it will keep the original file intact, but it overly complicates the subsequent animation process, because you're having to animate around the structure of the armature instead of just being able to animate the character as it should be animated. It'll make a bit more sense once we tidy up. So we've got tail, which is now torso. So torso is probably the tail. Oh no, torso is the legs. Toes, they're still there. So we don't have bones for the tail yet. So tail. So note as well that one of the interesting things about this is you can have, to a certain extent, you can have multiple groups carrying the same name. So tail, so we need to rename that tail to torso. So double click, but we've got torso, but torso is now the legs. So we can double click, rename that to legs, deselect, and then we want tail, and we need to rename that torso. So double click, torso. So if we switch back to object mode, so we now have the elements corrected. So the tailbone controls the tail of the mesh. The torso bone controls, well, it controls a bit more than it should at the moment because we're still in the midst of adjusting the skeleton. So it controls the torso and the feet, and then we've got the feet still, or the toes still controlling the feet. So what we can do now, so we need to add a leg bone. So right click the lower node of the head of the torso bone and extrude, press the E key, and just extrude downwards. That adds a new bone. We'll call this legs. And that should automatically, so it does automatically. So if you have your groups, your vertex groups set up within the mesh, if you have them set up, when you add bones, and name them whatever the vertex group is that you want to control, it'll automatically pick up the fact that there's a vertex group named that and make an associative link between the bone and the mesh element. So what we also need to do is change the relationship of the toes so they are linked with the legs. So when the legs move, the toes move, because at the moment the torso is what controls the toes. We want to change that. So edit mode. So everything to do with modifying the physical structure of the armature is done in edit mode. So right click the bone. We want to change the relationship, so we need to change its parent. So bone properties. In the relations subsection, that's this bit, we've got the parent selector. So we want to click the bone and select legs. And I don't know if this will come through in the video or in the stream, but there's a dashed line that currently links the toe bone with the tail end of the torso bone. That will change. So right click the bone and select legs. So if I now move that relationship line is now linked to the toes, to the legs. But what we can also do, so let's just double check this. So if we now rotate the leg bone, it rotates the toes as well. What we can also do edit mode again. So that's obviously toggling back and forth between edit mode and object mode, but because the armature is actually in pose mode, or it was in pose mode, when you toggle using the tab key, when you toggle between edit mode and pose mode, you are literally doing that. You are toggling between edit mode and pose mode, so you're kind of bypassing object mode, so you don't need to keep going. So we're in pose mode, go to object mode and then to edit mode. You just press the tab key, switch to pose mode, and once you're in pose mode you can just toggle between pose mode and edit mode, so you can make your changes to the armature and immediately test them in pose mode. So what we can do with the toes bone is we can connect these. So let me just undo that. So let's zoom in a little bit closer. Yeah, I mean, the UV mapping, Debs is just saying that she gets stuck with the UV mapping. The UV mapping it's tricky to get your head around in terms of what it is that you need to do. As we've discussed before, whether the object is for you or whether it's to be derived from by others, and how that determines how you unwrap the object and texture it. But once you've got past that, the process of actually UV mapping is relatively straightforward. So back to task. So what we're going to do is connect the toe bone to the leg bone. Cue the song. Leg bone. And what this will do is link these two control spheres together. So right click the toes bone and click the connected option, and it links the two spheres together. This just ensures that the pivot point of both bones is located in the same location. So now again, test, that's okay, test, and that's okay. Yeah, so somebody will have to find that song, that nursery rhyme, I guess it is, and play it whenever we start talking about bones. So we're on torso. That controls the tail. Whoops, that controls the tail. And we can modify this a little bit so that so it's orientated relative to the tail. But what we want to do with this is we want to do it in a way that its rotation, its point of rotation, matches the tail. So right click just to select it and just move it into approximately the right place. And then what we can do is, I wonder if a quick way to do this might be active element, median point, individual origin. Yeah, so what we'd have to do is we need to adjust this bone with a bit more precision than we've done with the other bones. So we need to keep this pivot point relative to the tail as it joins the torso. So right click the head end of the bone, Shift S, or I think it says select, no, snap. So armature, snap, and we want cursor to selected. So the 3D cursor moves there. We then want to change the pivot to the 3D cursor. So when we select the bone, the 3D widget stays where it is at the cursor's location. So we can then press the R key and just tilt the bone based on that pivot point, and then just line the bone up with the tail. And that moves the tail, that moves the torso, whoops, based on the pivot point at the moment. So let's reset that so that it's active element. That's good. So next we need to add a head bone. So a quick way to do this is right click the torso bone and then just do Shift D or duplicate. So that's armature, duplicate, and that creates a new bone. Just right click to reset, and then using your widget or press the G key, just move it to a position that's relative to the head. So we're just going to put it center of mass for now. Rename this head, so we've got it selected. Bone properties, head, and this should control this head section, which it does. Now, with the tail, the pivot point for that is obvious. It's where the tail joins the body. So that means when that bone moves, the tail moves using that pivot point. Similar for the torso. When we move that, the entire torso moves at the pivot point of essentially what the I guess that's the turkey's hips, top of its legs. The head currently rotates center of mass. Now let's go into the 3D view to see this a bit more clearly. Now, depending on where you position the bone, that will determine how the mesh articulates. That's obvious for things like the tail and the torso. But not so much with the head. Because at the moment, center of mass, it literally just tilts up and down. But from the side view, if we reposition this, say bottom corner, that changes the behavior of the rotation. So that's something to keep in mind when you are doing things like this. So center of mass, it just basically tips the head center of mass as you would expect. Down in the bottom corner, the head behaves in a different way. So if it's moved, let's put it down at the bottom, keep it down at the bottom. But if we keep the pivot point where the head effectively joins the body, we then change the way the head pivots again. And this time, you've got to watch out for overlap. The top section of the head is poking through the body. So where you position bones, so if you position it at the top, so we would get a upward looking animation all the time. So center of mass, or for this character, center of mass or bottom corner. I think bottom corner. So where you position the bones relative to what it is that you are manipulating obviously changes the way that that particular associated mesh section articulates. So you don't always need to keep things center of mass or center of a pivot point in an obvious way. You can be less obvious but still get a similar degree of articulation or more interesting articulation. So where it might be obvious for things like the tail and eventually the wings when we do that, the torso, for things like the head, you don't specifically need to keep it center of mass or at a specific pivot point where you might expect it to be. But either way, you have to keep you have to be aware of the way that the mesh, when it does articulate, you have to watch out for intersections or where the mesh pokes through something. So drop this down here. So we've got our head bone, but at the moment it's not controlled by the torso. So we need to create a link between the two. So edit mode, select the head bone, bone properties, and down to the relations tab, click the bone, and we want, where's torso? There's torso. So again, we've got, there is no relationship line between the head bone and the torso bone. So when we do this, one should appear. So now we do. So that now means that the torso bone controls the head. Yeah, a very wee dotted line. You can change the color of these in preferences, but right, so we've got legs, we've got legs, toes, tail, head. We now need to add wings. I think we'll do one bone per wing. So again, edit mode, because we're modifying the structure of the armature. Switch to front view, and again we could add bones, but it's easiest just to do Shift D and create a duplicate. And this also, because that bone's already linked to the torso bone, by creating a duplicate, it carries that link association with it. So just right click to reset, move it across and into position, right click the head bone again, Shift D, duplicate, and move that across. So we've now got two bones, one for each wing, but we need to rename them or we need to create separate vertex groups for the wings, wing bones. So let's just rename these. So this will be its right wing because it's on the right side. So bone properties, left click the input field and wing dot L, no, that's dot R, and then wing dot L. So these currently don't control anything. And we still have our relationship line, which is linked to the torso. That should come through on screen. So we need to create two, well, we need to modify the one of the vertex groups and then just duplicate it. So right click the mesh, edit mode, deselect everything just to make sure. So we've got wings. Select, that's okay. So deselect, just double click that to rename it wings.r. Double check the assignment. Oh, wings. We've got wing. So we want it to be wing. Now it should work. Yes, and it moves both of them obviously because they're both called wing.r. So we need to create a new vertex group. You can duplicate them, copy and paste, but it's often just easiest just to create a new group. Select the mesh element that we want. That's the C key, C for Charlie. That's for the paint select option. Left click. It's not letting me click the wing. That's obviously selected more than was needed, but as often happens with busy meshes, so this paint select is handy because we want to avoid selecting or deselecting this face. So this gives us some precision to avoid doing that by just middle click, using middle mouse click to deselect that particular element, and then you right click just to cancel the selector. So that's all selected. Assign the group. Deselect. Let's double check. Yep, so we can rename that wing.l. Double check again. But again, we have to make sure that we haven't still got wings assigned to it, which we do. So in this instance, select the vertex group that we want to remove, and then using paint select, we can deselect the one that we want to keep associated with that particular group, which is wing.r, but we can now remove it from wing.l. So with it still selected, just click remove. And that will remove that from the group so that we now have our assignment set up. So this should give us two bones that now independently control the wings. And we can change the pivot point of these as well, so we'll do that whilst we're doing this. Edit mode. So we want to select both bones, so right click one and then shift right click the other, and use the keyboard shortcuts, numpad keys, so that's front, side, left, right, and drop out in and out of perspective mode using the numpad key 5, and this helps you align things. So once we've got those selected, just use your widget or free translate with the G key, and then left click so that we set a pivot point, and we can rotate these to align with the wing. It doesn't necessarily affect anything, but as with the tail, if we want to do that, we have to select the bottom node, Shift S or Armature snap cursor to selected, and then right click the two bones, so that's Shift right click, and then we can set the pivot point. Whoops, wrong one. Pivot point to the 3D cursor, press the R key and just rotate them round. And then again test. Oh, we've still got the pivot point set, so active element or median point. That controls that wing, and that controls that wing. So what we should have now is, so let me save the file. Save as 27. So this is our turkey structure. So let me invert the selection. Whoops, wrong one. Invert the selection, hide all of that stuff for the moment. So that is our skeletal structure. We could add 2 leg bones, and well, we could add another bone for the leg and another bone for the foot, so that we have 2 leg bones and 2 feet. But in this particular instance, it's not necessary. But that is our skeletal structure. Ooh, that's still in the scene. Let's move that out of the way. But the actual skeletal structure is the furniture root node, the mesh or the turkey control node, which is the one that moves, and then we've got the armature. It's kind of funny that it's actually kept the, or part of the animation, so that's, we haven't destroyed as much as we thought we might have done. So that's the actual skeletal structure of the furniture item. Just a quick question. Yeah, Hot Rod. the naming that you use for, you can use any name you want, essentially, as long as you have an association between the bone that it's, whatever the bone is called, as long as you have a vertex group that is called exactly the same name as a bone, it doesn't matter what the bones are called. The whole .L and .R thing is to represent, as you probably guessed, the left and the right side of the character. But specifically, the .L and the .R, the appends, they can be used. So if this, I can't remember how we built the character. I don't think we used a symmetrical. So the character is essentially three sub. The skeleton is basically three sub elements. You've got this central aspect to it, and then you've got the right side, which is selected on the character's left, and then the left side. So there are essentially three bits to the armature. What's common to all is, generally speaking, the middle bit, which corresponds generally to the spine, the base of the spine, all the way up to the neck and to the head. But you can't control, well, if you want the wings to move, you can't really do anything with this central aspect. So you create a left and a right. But if this character was symmetrical, what you can do is you can create half your rig. So using, so what that would basically mean is you are splitting the creation process of the armature into sections. So you essentially create the middle bit, the spine, all the way up to the head, and then you create one half of the character. So you have a left hip, a left thigh, a left lower leg, calf muscle or calf, a left foot and left toes, and then maybe left shoulder, left bicep, left wrist, left hand. And then what you can do is, if you use the .L append for that bit of the armature, you can duplicate it and mirror it and automatically switch it so the bone names are appended .R. And there's a feature for that. I can't remember where it is off the top of my head. Armature, yeah, flip names, there it is. So yes, so let's say for the sake of argument this bone doesn't exist, so I'm just going to hide it. So you built your character. You built your, let me just unhide everything. Whoops, wrong one. So this is a pretty symmetrical character. So let's say for the sake of argument you built this in a way where only half of it was made, because what you were doing was you were mirroring this across from left to right. So you basically just make one half of the character. The same is then applied to the armature. You don't necessarily need to make both sides of the armature. You just make one, you make your central control spine, so from the lower spine all the way up to the head, and then you add your appendages on one side. So left arm, all the bones for the arm, left leg, all the bones for the leg. You can then duplicate them. So you'd select all the bones on the left that were corresponding to the appendages, so all the arm bones, all the leg bones, all the feet bones, duplicate, and you can mirror it across the central axis. So it would duplicate, mirror across, and because you've got the .L appends, when you mirror the duplicates, they will be named, they'll have the automatic .001 append to them. Blender understands that, which then gives us this tool in Armature to flip the names. So it reads and understands that one side is called .l, and it knows that in you doing that, the other side that you are flipping the names for, it's all selection based again. So you'd have your duplicates on this side, and they would be selected. And you go into Armature, flip names, and it automatically adjusts the names. .r in this instance because we're on the right side, or .l if you reversed the process and you made the right side first. So yes, it's a good habit to get into, but for this type of character it's not particularly important because it's only got 2 bones on the left and the right, or 2 bones describing the left and the right, I should say. Unhide. So that is our character rig, modified character rig. So let's see what the animations has done. Yeah, so we might have to destroy this, which is fine. That's quite funny. So save the file, save as, and we will call it quits there for today because this is quite tricky to get your head round because of all the adjustments that have been made. So in the next session what we'll do is we'll go over, we'll recap what we've done, and then we'll essentially destroy this animation. This is the animation that's associated with the mesh itself, not the node. We can keep that because nothing's been done to that. It doesn't change. But whilst we're on this this point, Liana asked a question in the last session about how you determine where you put the hops. So we said that what you want to do is multiply the animation that you have associated with the mesh itself. So in this instance I think it was 70 frames. So the hopping up and down lasts for 70 frames. So you would then set this motion multiples of that, so you give yourself time for the character to hop around the sequence. You can do so if we want it to hop 3 times. That means, so internet math warning, so 3 7's 21, so that's 210 frames, which puts us here. But Liana's specific question wasn't so much the number of hops within the sequence, it was where to put the hops. So what you can do is, knowing that a sequence is 70 frames, you can position your keyframes. So we've got this set up so that it moves quite a distance in, so where is 70? There's 70 frames. So that's how far the cube moves, the control cube moves, in the same time frame it takes for the character to hop up and down. So it's essentially hopping up, and according to the control node, it's hopping and is able somehow to miraculously twist in the air. Maybe it flaps its wings, who knows. It's miraculously able to twist in the air and land at a different location. So what you can do is, even though we have 210 frames, which will allow the character to hop 3 times, what you can do is make adjustments to your major keyframes. So if we know that at frame 70 it's going to have completed a single hop cycle, we can place a keyframe. So this control node, instead of being where it is at, say, frame it's frame 28 because we stretched it out. So instead of that being at frame 28, that might be at, you could move that frame onwards so that the gap between frame 1 and the next frame is at frame 20. So let me just, I'll demonstrate. So box select all of those. You'd obviously have to do some adjustment. Whoops, undo that. So that would be frame 70. So from frame 1 to frame 70, we've got the character hopping up and down in its cycle once and moving forward this distance. So your next frame, or your next major keyframe, would be relative to where the character was going to go from this point, frame 70. So that's 70. Internet math, 2 7s, 14. So 140 would be the next frame. And from there, you'd then make adjustments between those 2 frames, and that's how you can be a bit more precise with the timing in terms of the number of frames each element rolls through in the duration that you've set. So it's you can do what we did, which is fine, and just set a motion track in place and just have this thing hopping regardless. But if you want more precision, you have to start thinking about the major frame placement in relation to the character's actual hopping animation. I'm just catching up with chat. That seems okay. So that's yes. So yes, it does, Hot Rod. It does make it better. It makes it more precise, but obviously it takes a lot more effort to work out because you know, if you wanted this to hop 3 times for the full cycle, you have to do quite a bit of finagling to try and get the control node around that loop in 210 frames whilst making the character look as if it's actually naturally hopping around it rather than hopping and twisting in midair without there being any indication that it can do that. So that was a question that was kind of a leftover from the previous session that Liana was asking about. So yes, you can just create a sequence of a certain duration just to get it to work and fit so that it all loops nicely. But if you want it to look more accurate, you have to be a bit more thoughtful with your major keyframes and then any in-between keyframes. So, in the next session, we'll go over destroying this sequence that we had previously and creating a new one. And it'll give us much more control over the character. But this is a animated furniture item, not a pet. So this is interesting from that point of view, in terms of having an animated pet as a furniture item. So, just any questions? Let's see if there are any more questions, and then if not, we'll call it quits there. Friends is asking, how do you purge unused textures? Well, if the texture is fully unused, in that it is not linked to anything, it's not been associated with a thing, it's not been assigned to anything. If you can check this. So select your you might have to select go into edit mode and activate the UV image editor so that you can see this. But if you click on the texture that you're wanting to check, if it's unused by anything, so nothing's using it whatsoever, you'll have, if you click on the Browse To button, the picture icon, and you look at the one that you want to see whether it's unused. If it is unused, to its right, the right of the name, you'll see the you'll see 0. If you see a 0, that means it's completely unused by anything. So what you can do is save a version of the file and just reload the project. The reloading should clear out any unused textures. If the 0 is not there, then what you can do in the outliner, you want to click on the data type selector and then click on Blender file. This is important. That'll list all the content that's in the file, and you should then be able to access, and if you just right click, is it material or textures? Is it Blender file? I did a video on this and I can't even remember how. Oh, there we go. So just right click on the thing that you want to delete. It's a bit, the selection method in this window is a little bit weird, and that's saying something for Blender. But if you right click on any one of the entries, don't try and left click and then do something, because it doesn't do anything. Whoops. Just right click and you'll get the menu that will allow you to delete the element that you want to remove. And that will permanently delete it from the file. So once you've done that, just resave the file or create a new version, and that asset will be removed from the file when you next reload. Oh, yes, components, hot rod, SketchUp components. Yes, as far as I'm aware, Blender doesn't do that. It doesn't function in the same way as SketchUp with regards to what are essentially grouped objects. So in Blender you have to kind of cheat, and you can cheat by using parenting. Again, I've done a video on this, which let me just double check. I'll drop this into the chat. Computer says no, it's too slow. Come on, computer. Oh, there it is. Copy link. So you want to look at organizing scenes in Blender using parent and group. That one. Oh, and of course it's going to show an advert now. So that's the video you want. Organizing scenes in Blender using parent and group. And that, it won't do exactly what you need in terms of how SketchUp does it, but this is an approximation, and it will do something of the sort. So but in Blender it's with if you think of the components element of SketchUp of being an organizational thing, then you can wrap your head around using parents and groups in Blender to do a similar sort of organizational function. But it's not, obviously not exactly the same. So that will help you organize your scene and your scene data. Yep, normal maps or baking ambient occlusion maps. There's all sorts of things that you can find on the YouTube channel. So, on that note then, that's those 2 extra points covered. So the usual, if you like what you see, subscribe, blah blah blah, etc, etc. I guess we have to start doing that now. So subscribe, you know you want to do it. Until next session, where we will I can't really answer your question, Frenzy, because it's actually quite it's more complicated to sort out in the time that we've got. So we'll probably have to do that in another session. But your other question about removing textures, that was answered. So if you just rewatch this stream once we're done, at about 1 minute 10, I guess 1 minute 20, you'll find the info for that. So we shall call it quits there until the next session, where we will do some more complicated animation. Bye for now.